Hello. Welcome, everyone. It is Monday. Now look at the music. This is programming music. This is what all the programmers listen to when they're coding. Anyway, it's Monday. We're playing this game, Exapunks. I heard it's a lot of reading manuals, apparently. It's a game where you program in an assembly-like language and read tutorials on how to do things. Yeah, there is. I know. I've seen. I literally have it open right now. You get to watch me read manuals. Anyway, well, let me welcome people. Welcome Stanley. Welcome Stream Elements. Welcome. Also, thank you Stanley for the 15 months. Welcome Tag Barrel, Defin, Slime Molder, Escapade, Michael, Zoe, Namington, Saw, Patricious, Potato, Yuyuko, and that's everyone. Everyone's here. Did I go to the local print shop to print it out? I did not. I'm just gonna be tabbing back and forth between the game and Firefox. Anyway, I'm not sure how accessible this stream is gonna be. You know, unlike the other programming game we played, which was, what was the name of that one? Human Resource Machine. This one, it was like, it's kind of like, you know, drag and drop. You can easily tell what's going on. This one, I don't know. People that haven't played this game, you might be very lost. I've never played this game. I'm probably going to be very lost. Anyway, you start off, I think there's lore. I don't really need to care about the lore, right? Imagine caring about lore. It's going to be like that Bitburners? Yeah, but like Bitburners was real programming. It was real JavaScript. Okay, whatever you want. Play cutscene. Someone's at the door. Can't remember. Who even could this be?
Hey, can you hear me?
Can you hear me? I can hear
you. For the phage?
This is assembly. It's like, it's similar to assembly.
Looks like you definitely need it.
We got voice acting. There's lore. I think, you know, you don't really need to care about the lore. Basically, what I just read up on the
It's
lore.
cheaper than the real deal, but
Basically,
it's pricey.
we are this programmer and we have some kind of like disease or something. We gotta earn money so that we don't die. Yeah. 700. We gotta get medicine so we don't die. And we need to hack things to get money.
That's dollars.
Yeah, $700.
Sorry. I don't set the price. It's not like any of that money goes to me.
Stream is only for the most hardcore Picross enjoyers. It's not even Picross.
Anyway.
Also, welcome. Thank you for the raid, Xenia Vex. What were you doing? Let me show you. Mario Kart 8 Deluxe. Hope you had a good stream. Welcome PS Bus. Welcome Xenia. You were just in time to watch me start this game. Everyone's gonna be very confused, including me, because I don't really know what's happening. Yeah, but workout. Okay, I've seen. So okay, I've to watch. Sorry, what am I saying? To prepare myself for this game. I know Northern Lion played a very long time ago, and before I streamed this yesterday I checked out his playthrough. He played the beginning of it, just to get a sense of like what is coming up. I don't want to be spending too much time just like going like, I don't know what's happening. I don't know what like this programming is. So I'm aware there's a manual. I've seen this thing. So you start this off, you're like manually typing things, right? And then presumably later you do similar things, but you program it, so you're not wasting time manually doing it. Probably, I don't know. You're just typing, you know, we're like, you know, data entry job typing things. You're like, how is he so slow at typing? I don't know. Mr. PL, what even is that? We should develop an algorithm. Whoops. Oh, what the what the heck is this button? I just pressed the wrong button. How do I go? Okay. I think I pressed Shift Tab or something. Oh, welcome Chicken Coop. NY strip. $70. Add truffles. $20. Filet mignon. $80. CHC. I don't know. Chicken, maybe. $12. Special order. $200. A lot of money. We've earned 10 cents. And you know we need $700. Welcome, Brooke.
Congratulations. You only need to do 6,999 more of these, and you'll have enough for today.
We start off doing mechanical Turk stuff. I already know this is
Don't worry about that right now.
It's Ember. Oh, it's Ember. Ember reference.
You need that medication
The
to
rat
stay
VTuber
alive,
Ember
right?
out here.
Well, guess what? I can get it to you. You'll need to start hacking again, though.
Gotta hack.
One hack, one dose. Easy. Deal?
I've forgotten how. You teach me how to
You're about
hack.
to remember.
You're gonna give me
Nah.
a PDF to read. I know. Welcome, Roger. Yeah, the rat. The rat is here. You've connected to the server. Anyone around? Hey, mutex. I know what that is. Mutual exclusion. That's it's a locking mechanism in code. Old friend Gast.
Hey,
Is all my name. This is his
about to give you
VTuber name,
something.
Gast. Small booklet of real paper. Trash World
can't
News.
hack like I used to. Whatever edge I had, but I had to keep doing something. Something to keep the culture alive, you know?
So true. Welcome,
Computers
Cryptic
are
Command.
running everything these days.
True.
Before long, human beings aren't even gonna have a say.
So true.
So now I equip people with knowledge.
It really says a lot about society.
The knowledge to make a computer do what you want on your terms. Anyway, I won't keep you. I know you like to be alone.
Let's literally look at this. It's literally the same. I mean, our glasses are different, but it's literally the same.
Hope you like what you see in the zine.
Okay, here is the the book. You gotta get a PDF. You gotta tab back and forth. I already have it loaded. It's in your program files, Steam apps. Okay, just go. Go. Can I go? Let's go. And then what? Trash World News, we have it. We go here, and go to the next one. Okay, this is where we actually program. I don't know where to put the chat, because I know the program is going to be on the left side. The hacking tutorial, I guess. Time that just right. Let's continue. Okay, now this is the thing we have to program in this little thing right here. Right, we're typing things. They have registers, you know. Let's take a look at the tutorial. So this is the this is the magazine that we were given. There's a tutorial right here. We don't need to read this. Imagine reading. You gotta read this though. This will tell you what to do. So basically, we have these robots, and each robot has its own set of code that it runs. You can make a new one, and they run, you know, maybe in parallel or in serial. I don't know, whatever. I think they run in parallel. Sometimes you need more of them. Sometimes you can work with just one of them. It is an EXA, an execution agent. Okay, and then you're writing instructions. Okay, they run at the same time. You write instructions. You tell them what to do. So let's see. Let's move this over there. It's code. It's a specific language designed for them. We have register. You can store data in the registers. Values can be numbers or keywords. You can read things. There's different types of registers. Some store values. Others interface to more advanced features, such as files. The F is the files. Okay, and then this is like a digital representation of the network. A host is a computer in the network. They can only exist inside a host. So this is like our computer. We're sending these things to other computers, and they run code on the computers. Because of performance, all hosts have a limit on number of X's they can contain. I see. Okay, the number of spaces tells you how many things can exist there. I see. It's like, you know, memory or CPU, I don't know. We have files that exist on the host. They take up space, but they have no code. They only store values. Okay, and then these things can create and delete files. And then what is this? Links. I see. So when you link, you are sending it to a different host. Yes. And then there's hardware registers that do something. I don't know. We'll find that out later. So we do the first tutorial. So we'll tell you. You got a link. So link is going to tell it to go through this link to this host. Link 800, right? If you run this, it's going to go. It goes to that host. Yeah, the network link. And then you tell it to grab. Okay, you tell it the first argument of grab is like the file that exists. I'll go back. You want a link? You want to grab 200. Okay, let me just read what it says to do. Move file 200 to the outbox. So basically, you got to grab the file. Then you got to go through link 800 again. Right? I think, maybe. Yes, and then you gotta drop the file. You take the file, put it there. Did the music just stop? What happened to the music? There's a drop command and halt. Halt will stop execution. Where's the music? What the frick is the music? Anyway, it runs many examples to check that your code is working. It's that easy. So easy. But where's the music, though? Where's the music? Did the music? What the frick? Isn't there supposed to be sound? What's happening? There's definitely supposed to be sound. Do I have to like close and reopen the game? Hold on. Let's reopen that. I don't know what happened. Go back to exapunks. There we go. We got the music right there. Okay. How do we resume? Yeah, we hacked too much. Okay, now we do tutorial 2. We can edit files. And I don't know where to put the chat. Maybe over here. If I make this small, put that there, and then put this over there. But then it's gonna block the instructions. I'm not like everyone else. I'm different. I'm in this for the fun. Okay, tutorial 2. Add the first 2 values of file 200. Multiply by the result of the third value. And then subtract the fourth value. Okay, so each file has items inside it. And we have instructions where we can read things from the file and write it somewhere else. So this is kind of like the arguments to the code we want to run. Multiply, add, so we want to add these two together. Multiply it by this one, and then subtract this one. And then append the result at the end of the file. So we want to add a value to the end, and then move it to the outbox. Okay, and then the tutorial will tell us the instructions we need to do it. So we already know we have to send it to the host, 800. We're going to grab file 200. Now this is teaching you about registers. Copy F. Okay, so the F register is presumably what we have in the file. So if we read from F, it's just gonna say, hold on, if we just play this. Go pick up the file. Okay, so the F register has the file that we have, and then presumably if we read, then we get this value. Copy F, okay, we can copy a value from the file to register X. Right, copy from the file to a temporary register. And then we have instructions for adding values and multiplying. Okay, so once you copy. Wait. Okay, so we have a thing. Okay, I see. This will just take the next value. So it's like a queue. Once you've read a file, a thing from F, it just goes away. Okay, you've got add I, and then you have X. The two things that we add, and then where we write the results. So add X, F, and then we put the result back in X, and then we want to multiply. Okay, so then we have molly. Right, and then we have, whoops, subtract, subi, xfx, and then we want to append the result to the end of the file. You gotta copy, and then you copy what's in your register back to F. I see. And then, okay, then you do link to go to the next host, and then you drop it in alt. You go to link 800, drop, and then it goes. Did it go? Is it working? What happened? What happened? Wait, hold on. Drop link 800, drop alt. It's good, right? Oh, you copy X to F. Oh, I see. I did it the opposite way. Oops, whoops. You gotta remember the order of operations. Yeah, Molt is literally Bellotron. The same thing. It's literally the same game. Anyways, why is this taking so long to run? Am I crazy if this makes me want to program x86 assembly? Why would you want to be programming in assembly? I think someone wrote a language that compiles down to this language. You could write in a higher level language and just like copy it into the game. Does it upset you that I will only provide medication only if you work for me? I don't even have a choice. Oh, you can fast work. Okay, maybe I will consider doing that. Agency severely constrained. This is a good idea. Okay, we go to the next tutorial. What do you think of your situation? Why all the questions? Collecting data. Receiving all of my personal information. Welcome, Pomflol. I need my tea before my brain can work with how this works. It's like complicated. It's not as straightforward as the other game we played, because there's like typing. Okay, file contains two values, a keyword and a number. Create a new file in the outbox. Copy these two values to it, swapping their order so that the number is first. And then delete it. Okay, so first we gotta go link to 800. Link to 799, right? You gotta jump between hosts. Go to 800, you go to 799. Then you pick up file. So what's the word for pickup? Hold on, let me check. Grab. It was grab. Grab 199, right? Now we have the file. And then we want to, if I remember, copy F. Right, we copy F we put it into X. And then we want to copy F again. Then we have the second thing. We put it into T, probably. I'm not even reading the tutorial. I'm just going to assume this is how it works. And then we want to copy. We want to... Wait, how do we clear the file, though? Okay, maybe I do actually need to read the tutorial. Communication between X's? Wait, what? $1.99. Did I like skip something? Is there not one? Oh, we just have to. Okay, there's no tutorial specifically on this. Wait, but no, there's a wipe instruction. This is where we gotta actually read. Oh, there's a one-way link. Okay. File that can only be accessed through a one-way link. The Exa that grabs the file will be trapped. What? You can create a new file with the make instruction. The file it creates will be empty by default, will automatically be held by the Exa that created it. And delete the file. Okay, so there's a one-way link. Oh, and then you can use M to communicate with the other Exa. It's like a message queue between your threads. If one Exa writes a value to the M register, another reads from M, the value gets transmitted. Oh, I see. If an Exa is reading the M register while no one's writing to it, it'll wait until another one picks up. Okay. Local and global mode. Okay. Okay, so we have a make instruction. You gotta add a new one. Okay, so this is a one-way, I see. This is a one-way link because there's no way to go back. Once you go this way, you're stuck there. So you want to send the first guy over there. And then you want the second guy to create a file. Make, right? XB is going to be the one that goes there. You want to make the file. You want to link 800. From Handflow, welcome watch feature. You want to link 800 again. So now XB is going to be over here. Now for this one, you want this one to read the file. Okay, so this stuff is fine, but then you gotta like copy to the M register. Copy, so we've copied values. I guess we don't need the T register, right? So we've read X, and then we copy F to M, and now this one who's over here, we now want to copy from M to the file that we're holding, and then do it again. But this guy now is going to copy what's in the X register back to M. Right, and then now this thing will have all the files. I guess we could have the make statement. Hold on, this one could be here. Right. So now this is done. How do you now? Okay, you can wipe the file then. And halt. Hit halt or stop. Halt, yes. And then this guy's got to drop it and halt. Okay, so first, go next, right? This guy goes here, this guy goes there. This one should now go to this one. Okay. And then it picks up the file, takes this one, writes it into M, right? And then it copies X to M. So this guy now he's written this thing, okay? And then write that one. Okay, it is written in reverse as we expect. And now it's done. Okay. I see. I understand. Simple is so easy. Everyone, this game is for babies. Having to write the file address. Imagine writing to file addresses. What do you really want? I don't even. There's one more tutorial to go. You're almost there. There's gonna be a lot of reading. Yes, you can do it. Positive encouragement is designed to increase activity. Oh, leave the brain stuff to me. I'm sure it will help. Okay, file 200 contains exactly one number, n. Create a new file in the outbox containing the numbers n through 0 in decreasing order. Then finish delete. Okay, this is going to teach you about loops. Okay, you got a link 800. Right? You go over there. You pick up the file. What does it take? What is it called? Take grab 200. And then you want to learn about loops. Loops and conditionals. A file that contains a sequence of numbers, you want something called a loop. You can use the test operation. If x, loop. If x is equal to 38, then it's true. Then, okay, then there's a t register. The t register. And their own test instructions aren't that useful if you combine them with conditional jump instructions. T jump and F jump. I'm going to assume this is like true jump. Yeah, true jump if true. F jump, jump is false. Okay. And then you use the mark instruction. It's like a go-to. So what we want to do, okay, we have mark, F jump, T jump, okay. So go over here. And then we want to go to link 800. We want to go back here. And then you want to check. You want if the value is equal to 0. Wishy. Copy. Okay, you have to set. Okay, you can just copy a literal value to a register. So source 0, destination x. So now x has the value 0. And then you want to loop, right? And why are we copying 0? No, this is just an example. Okay. So I want to copy the file to the x register. So we'll have 200 will be in x. And then we want to loop. So we do mark loop. Right, that'll be the start of the loop. And then if what's in the x register is greater than 0, how do you check? You have to test. Test x is there a greater than and equal to? I guess if it's just equal to, right? It's equal to. Test. Is it only equal? There's only equal. Okay, it's probably one test for like -1. You know, off by 1 errors. If it is equal to -1, then we're done. So you want to go and drop. Okay, what if it's not equal? Hold on. If it's not equal, true. If it hold on, test x. It's negative. If it's -1, then you're done. So you want to t jump to. Yeah, if it's false, wait. Okay, hold on. Complex. This is complicated. T jump. Mark. Non. This is done. This is when you're done. Okay, well, if you're done, you want to jump here. If it's true, jump to done. Is that how it works? Right. And then if it's not, it'll go to the next instruction. And so we want to subtract. We want to subby. Is that how it works? Subby? Subi. I'm going to subtract x 1 and put it back into x. And then you want to... How do you unconditionally jump? Can you just jump? there just a straight up just regular jump unconditionally? No, so then I guess we need to okay, then we have to we should put the test X at the after this. Test. I guess you could do that, you know. There's just a regular jump. Okay, but we can do this. If we do this, you put the loop at the end. But then what if it starts off as 0, huh? I don't know. Okay, test X. And then, okay, we're just moving this. Is there a way to copy paste? And then we T jump to loop. If it is true, yes. And then if it's not, I guess we don't need mark done. If it's not, it'll just go here. F jump. If it's false, if it's not equal to -1, copy value to T. I don't know. Maybe. Okay, but otherwise, then you're done. Then you want to. Oh, you have to create a file. Wait, you have to create. Hold on. Create a file in the outbox. We can't just take the old file. We have to make a file. Okay. Make. And we have to drop. Wait, what? So we're not writing back to this file. We have to like make to the file. No, Precure, I did not do whatever that is because I don't even know what spot pass is. Make. Okay, we want to make a file. Wait. Go to the link. Make. We want to make a file. We have to. Hold on. We have to pick up the file. In our loop, we have to like pick up the file and then pick up the other file. Or we could have a new X that does it. No, we probably don't want to do that. Okay, what if we do the link? We have to make a file. There's a two-way link. Okay, well we grab the file. We drop 200, right? What is the ID of the file that we create? If we just make a file, how do we know the ID of the file? Like, how do we pick the file back up? I don't know. Grab 200, drop 200. Can we not drop 200? Too many operands? Hold on. If we just make, how do we pick it back up? Let me just try this. So we made, oh, it's 400. But how do we know that it's 400? Is it just automatically 400? So what's the deal here? We can grab 400. Work loop. Grab. Want to grab the original file, which is 200. We want to copy from the file into X. Wait, I guess we only need to read it once. We don't need to. Wait, okay, what am I doing? Here, okay, we copy from the file to get the original value, and that's we don't need to pick it up again. So we will read F into X, and then we just go and we make file. Is it not read? Copy it. And we make the file, and then we don't need to redo this. And then we will grab. What is it? Drop? Is it drop? Drop. Drop. Grab. Okay, we can just delete the file immediately. Fx drop. What is it? Wipe. The command is called wipe, right? Where's this? Yes, wipe. Okay, you wipe and then you make another file. Drop. Okay, so we go here, we pick up the file, we copy the value into X. Okay, there's 9. Well, to make a new file, we've deleted the file, we made a new file. And then we subtract. Wait, do we write? Oh, we need to include n as well. Also, I'm not writing to the file. Okay, hold on. We want to write the file. To copy X to the file and then subtract. Yes. That does appear to work. And then we're done. Are we done? Is this working? It's not working. Not working. Look at that. Took a while. Anyway, I don't really know what Spot Pass is. It's Street Pass, but from Nintendo and online. I don't really care that much. It's fine. My 3DS is pretty much... The battery life on my 3DS is pretty much dead. It's time to do some real hacking. Okay, that was the tutorial. And now we're doing the real programming. Pizza. A free pizza. You're giving me $700 worth of medication for stealing a pizza? You want a pizza? Okay, what are we doing here? Append your order. File 300 to the end of the order list. File 200. All orders, including yours, will consist of exactly 5 keywords. This is a lot more complicated. What the heck is this? What is this stuff? Okay, so we want to... so our file 300 has things. So we want to... is it take or pick? What is it? Grab. It was grab 300. Link 800. So now it's going to be over here. And then we want to append my order file 300 to the end of the order list. We want to take all of our files, all of these, and put them into here. So what are we doing? We're going to copy from the file we're holding into the X register. So now we'll have... this thing is going to be in X. And then we want to drop it. And then we want to grab 200. And we want to write the value into that. And then we just keep going. It'll have exactly 5 keywords. Okay. So we want to loop this. Then grab 300. You want this to be in a loop. Mark loop. Now we only want to loop 5 times. So we want to set, I guess the T register could be something. Watch a T, welcome love key. Copy 5 to T. And then if T is equal to 0, no, this test T equals 0. If it is equal to 0, then if it's not equal to 0, you go to loop. But you have to decrement T. So you want to subi T1 back into T. I think. Let me try this. Oh wait, we got a halt as well. drop. Do we need to dispose the file? Probably not, right? Leave no trace. Okay, so we gotta grab 300, wipe, and halt. Okay, let's try this. We grab this, we go over there, we pick up 200. No, we pick up 200. We drop. Cannot grab a second file. Hold on. Okay, hold on. Grab. Because we're already grabbing. We want to move this to here. Right at 300. So maybe it's not sub integer, it's sub immediate. Let's see. I don't know. We go there, we drop this one. We copy our order to X. Then we grab 200 and then we write it into, sorry, we grab, 200. We wrote it there. Drop it. We grab our original file. T is not equal to 0. So we loop again. Okay. And then eventually we'll have written all the things, maybe. Are we writing? I can't tell if we're writing things. Wait, why is T... Hold on. Why is T 0? Why is T switching between 0 and negative? Test T equals 0. T is -1. Do we have like an off by 1 error? T is equal to -1. Let's just play this. Is it going? It's not even working. We have to debug. We gotta debug the issues here. Okay, we go there. We do this. We copy. Copy over there. What's happening? Are we good? Did I not halt? I did halt. Okay, so what is the issue? What did I do wrong here? Grab 300. We go over there. We drop it. Copy F to X. That's fine. And then we have this one. This one's there. Wait, when we drop the file, does it reset the pointer into the file? Test T is not equal to -1, so it goes to, wait, it goes to 0. Why did T go to 0? Oh, right, the T, no, T is the true and false register. I need to use a different register. What am I doing? TF. F is the file. M is the sending to another thing. Right. That's why it's resetting, because I'm using the wrong register. Is there like another... Is there like another register we can use? Or do we have to make a new one to hold the data? Because X will mark how many times we need to loop. And then we have no other way to have that counter without making a new one, right? I think. Wait, do we even need to? No, yeah, because F is always going to have. Okay, maybe we need a new one. Can someone confirm? Is someone going to be like, actually, you don't need two of them? I don't know. Okay, so XB is going to be the second. XB is going to be the one writing the 200. We want to link 800. We want to grab 200. And then we want to repeatedly read until there's nothing left. But then how does XB note that it's done? Then wouldn't XB also need a counter? Do they cover this in the tutorial? X is a general purpose register. T is used for this stuff. The F register has the file. Pass the value through M. Yeah, like you could pass wait. I guess XB, I guess every time XB reads something, it could pass something back. What? Tutorial doesn't cover it. We have register. We only have one register for data. Do I need a second guy? Well, how do I know how to like? I wanna loop through this thing 5 times. Unless there's a way to test whether the file is empty. If you read from something and it's empty, what happens? Did I see the eclipse? I did not. It was cloudy here, and also New York isn't in the total whatever line. Also welcome Hongtown. So I did not see it. Hold on. Okay, so the heck is Swizz? Swizzle the value? We're not up to that yet. Does anyone know? How do I... Wait, are there multiple... Wait, what is R? There's a jump. Jump. Okay, we're there. Yeah, there's a jump. How do we loop exactly 5 times, but also hold on to the value? We're reading from here. Am I stupid? What am I doing? Hold on, what if we just read... Can I like just like copy all this? Copy. What does this button do? These buttons are not labeled. I don't know what this does. Oh, what the heck is this? Oh, you can move it into its own window. Look at that. Move it back. What is this? You can collapse it. Okay, you wanna loop exactly 5 times. But how? So you want the if we have 2 of them, and we want one of them to write 5 times. Is that all the manual has? No, but I'm assuming that if we need to know this stuff, it'll just tell us. You can use M. Even I thought M would block. If you write to M, hold on. Writes to M, it will be stored in the outgoing message slot until another EXA reads from M. But can you read what you wrote? Maybe we can just use M then. Let me try it. Copy, instead of copying the T, copy to M. So M will be our loop count. What is this? This is not allowed. Register M is used more than once. Can we not copy from... What is... Oh yeah, you can create a file. Hold on, Subi. Value. Oh, you can make a file. Oh yeah, okay. There's really like no other way to do it. We have to use a file to store our loop counter. It was kind of strange. Subi. Write the result. You can't write the value. Wait, hold on. Addy. Calculate x plus f. And write the result to x. Why can't we write back to m? It's because it's a special register, so we can't. And documentation specifically. And the value of the first operand to the second. Store the result in the third operand. Yes. Okay, so I guess we need a file. We need a file to... We don't need a file? Or no, but we don't have a register R. We have to write it to X. R is just a general... We only have these registers. R is a placeholder for X or T or F or M. You can add it. Tell me you can add 0 to 5. Wouldn't that just be... I guess we have to make a file then. Okay, so we need a file to hold our loop counter. It's kind of weird. Alright. Surely there's a better... No, we already have a file. Look, we have other files here. Hold on. That's why they're there. I just realized. We don't need to make a file. There's empty files right there. Okay. So we can grab... So we'll use file 280 as our counter. Grab. Got this one. I want to grab 280. We want to copy 5 to the file. And then we drop. How much is this game? I don't remember. It was on sale. Probably under $10 when it was on sale. So I want to drop. This is literally like the first thing after the tutorial. Okay. We want to copy to the file and then we drop it. And then we have to pick up the original file. This file 300 has our order that we want to write. So we copy that into the X register. We drop it, we grab the file we want to write to. Right, and then, well, that's there. And then we want to grab our temp file, our counter file, which is 280. And we want to copy the file value into, like, can we just subtract directly from the file? We can't. So subi from file 1 and write it back into file and then drop. And then we want to test. Hold on, we want to, the file is equal. Okay, but we don't want to go. To test if the file that we're holding has a value of 0. If it does have, if it's not 0, then you repeat. Alright. If it is, then you drop the file. Wait. Okay, I don't know. Let's see what this does. We also have to wipe the file. We have to file. Okay. So we start. We go here. We go to 200. We drop it. We grab 280. 280, and then we write. Hold on, let me put myself here. We have file 280 here. Where's 280? 280 is what we're holding. Oh, there's stuff already in the file. Oh, man. So I guess we do need to make a file. Oh, there is stuff. There is stuff in here. Okay, never mind. Okay, we have to make a file. Don't grab 280. Make your own file. But how do we know the ID of the file we just made? Do we have to test it? 300. Is it 300? 400. Is it always 400? Okay, so instead of 280, 400. Grab 400. Is there a way to name the file? That one. File. Make file. Communication. Drop file. File R. Copy the ID of the held file into the register. Okay. But then we need like a register that we need to like keep track of. But then we need that register for other stuff. We could have an exa that holds the value of the register. Maybe it's just 400. Is it always 400? What if we just assume that it's 400? Oh wait, test ELN. Hold on. Wait, we don't even. Okay, hold on. We could just do this. I missed this instruction. We don't need to hard code 5 times. File point is currently at end of file. Just set. Okay, then I've overcomplicated this. I thought, you know, that they would teach you these things in the tutorial. Anyway, let me hydrate though. Alright, I've hydrated. I've overcomplicated. Also, let me go to my redeems page. Forgot to do that. Man. We need more backseaters here. The people who played this game, you gotta be like, Wolfie, don't you know there's an instruction where it tells you whether the file's empty. Okay, so we're gonna get rid of all this. We don't need this. Get all this out of here. So we want to, you don't need to test any of this stuff. You know, let's just delete it. Let's just start over from scratch. Delete everything. Okay, we want to grab 300. We want to link to 800. That's EOF. Yes. Okay, so we want to drop. We want to grab, we want to read, copy, file into X, our X register. We want to drop it. We want to grab the file we want to write into, which is 300. Grab 300. Copy X into F. And then drop it. And then we want to grab our order again. Hold on. The thing we're writing to is file 200. Okay, grab 200. And then we want to test if we're at the end of file. And if it is, then if it's not, then we want to loop. Mark loop. Okay, so if T jump, F jump, if it's not end of file, we want to go to loop. Otherwise, then we're done. We want to wipe the file, which is 300. And then we want to okay, we go here, 200. 200. Okay, that's there. Grab our original file. It's not end of file. Wait, why is this not advancing? Is it that every time we let go of the file, it restarts from the beginning? Is that it? It does appear to be. Okay, so maybe we need a second one. A second one. Okay. Oh, man. So we have one that holds onto the file. Another one that is just writing. And then you can use another signal to tell it that it's done, maybe. Perhaps. Let's skim the manual. No. Imagine reading random numbers. No, to wipe the file, void. Remove the value. Oh, you can remove the value. Void F. Void F. So you want to copy and void. Let's see. I think we're done. We have not done it. It's not done yet. Hold on. Grabbed. Okay, we copy the value. We void. Wait, we voided the other thing. We voided. Hold on. What happened to this one? Waiting. What happened to the first line? We copied F to X. We void. Okay, copy. Does void write it to anywhere? It doesn't. Copy FX before the loop. You have to copy. Alright, because we do it. Wait. Go to copy, we void F. Drop, and grab the file, we write it. Drop. Grab. But does a copy, so copy advances the pointer. But hold on. What's in the file? How do we get it to like wait, hold on. I guess this is working. Something here, no, this works. What do I need the copy for? Does void, what does void do? Remove the void at the end of the loop. If I void at the end of the loop, isn't that gonna void? Oh, we could drop the file and then when we pick it up again. Right. We could pick up the file and then... No, I get it. You read the thing, you write it, and then, yeah, at the end, then you void it. Before you grab, void 300. 300 has our thing. So after we grab, we void it. This one there. Okay. This one, okay, I think that works. It doesn't work. Something does not work. Hold on. Mark loop, drop, grab 200. Oh, we grabbed the wrong thing. Need to copy back and move. Yes. So we have grabbed file 300. We copy to there. We drop it. We grab the file to write to. We write to the file. We drop it. We grab our original file. And then where's my void? Did I not void it? Void. Void F. Yes, we void F. And then if we're at the end of the file, if we're not at the end of the file, then continue. Otherwise, wipe the file and halt. think that should work, right? That doesn't work. What are we doing? Hold on. Let's start here. Okay, we go there. We copy F to X, right? So that has the address. And grab the next file. We then write it to 200, which we've done. We grab our original file. Yes. And then we void. This thing should now be removed. Okay, it is removed. We're not at end of file. So we repeat. Go back. And then we copy this to F. Grab the next one. We are supposed to append to the new file. Oh, to the end. Oh, frick. Why did they make this so complicated? As append to the end. So how do we go to the end of the file? Seek. You have to seek to the end. If seek would move the file past the beginning. Oh, you can use seek to 999 to move the. Okay. Okay. Man, what the frick? Okay, so we gotta grab. Before we copy, seek to 9999. Should be it. They made like the first thing after the tutorial is like, I feel like they could have had a few more steps in there, like maybe like teach you to seek to the end of the file first, teach you to whatever, it's fine. Seek 999 was smarter than. What did you do? Did you like copy everything and then write it back? In the file tests. Ian. It's why you're not even a real person. I knew it. Told you. Well, you can't say that. I'm not surprised at all. The pimp. Real, I'll have to remember that. Okay, next one. Now that we understand everything there is to know about the game, everything is just going to be really easy now. Pizza.
Don't look too surprised. I'm an independent operator.
Pizza. Where's her hair? Didn't she have hair? I guess it's under the head.
Economy like this, you gotta. So here's your pizza, and here's your other packet.
Unlabeled
Good
bottle.
work getting that money together. If there's anything else.
$700 for pizza. Alright. Next puzzle. About that left arm, the medicine stops your condition from spreading. Can't fix, you'll need to take care of that. Hack my own body? Exactly. Whoa, you can hack your own body. What is this? Nerve. Yo, Nerve. That's a reference to Evangelion. Hold on, what does it say? Relay all nerve signals. Read a value from the nerve connected to your central nervous system. Relay it to the nerve connected to your arm. Clamping the value so it never goes below -120 or above 50. Repeat ad infinitum. This takes place inside a network you can control. It's not necessary to leave no trace. Nerve is a hardware register, not a file. You can use it directly in your code like any other register. Ooh. Get right to Nerve. For more information on the phage, see debugging the phage. Debugging the phage. Put this up there. We have a disease that knows about the phage. Previous map had lots of hardware registers we could have used. It is true. But it does stuff though. What if we want to leave no trace, right? If we're writing stuff to those registers. I don't know. Okay, mystery disease known as the phage. Something. Interacting with the phage nodes as exa hosts. So Delise, birthday's in 6 days. Happy early birthday. Placing the HD10's probes with conductive high precision tweezers. Projecting hexes. Okay, this is I don't know. Okay, we want to read a value from the nerve connected to your central nervous system. Relay it to the nerve connected to your arm. So we want to go from here. Oh, we want to like go here, traverse across, and then right to here. And then repeating forever. But we have to clamp the value. Okay, so we want to link 800. Copy. Is this the syntax? Registers. How do I find registers? Just hashtag something. Do you need 2 guys for this? Could, maybe. I mean, yeah, you could have, I guess you don't need to like have him go back and forth. You can have one guy go over there, one guy go over here, and just write the value. That's probably more efficient. Copy nerve to... Okay, so we'll have a second guy. Link 800. Link 1. Link 1. Link 1. Link 1. Is link -1 free? What do you mean by free? Or is this is not a one-way thing, is it? Yeah, if it was a one-way thing, I think it would just not have it there. Going back. I think it's fine. We've never done it before, but I assume it's fine. Like, we could read and then go back, but I feel like, you know, maybe we can have 2 of them. Maybe that'd be cool. So we can copy from nerve to M. And then the second guy, copy from M to nerve. I'm assuming this is the right syntax. I can't find where it says it. The next thing goes into highway signs. Where is the syntax for hardware registers? Hardware. Oh no, yeah, okay, you can. It is like that. It's like okay. So then we just loop, but we have to check whether the value is below -120. So we want to mark loop. Copy nerve to M. If M past M. Is there like greater than or just equal to? Because we've only been testing equal to. Okay, there is less than and greater than. So if copy nerve to X. Past X is greater than -120. If it is greater than 120, we want to write 120 or -120. Sorry, hold on. This one. We'll have to test M on the receiver. I guess the sender could just send. We could do the clamping either on the sender side or the receiver side. I'm going to do it on the sender side. We test. It was greater than -120, then it's fine. We're going to test if it's less than 50. If it is... If it's less than 120, then we want to write 120. So that is so true. You could test positive. Yeah, then you have less jumps. So true. Genius. So this one will test the negative bounds. If it is less than 120, Then I really hate not having like, you know, like being able to do this. If else, you have to like mark things. Okay, so we test if it is less than. It's less than. Copy. If it is less than. No, you have to do a jump somewhere. If it is true. So if this thing being true, it means if it is less than 120. So you want to. What if we did test it for false? If it's not less than 120. No, you want this. Is there a better way to do this? I just want to have like more loops, more marks. Okay, mark clamp. Okay, so if it is less than, jump to clamp. Within clamp, you have to copy -120 to M, and then jump to loop. And then for this one, yeah, you could copy it to X. That's true. Copy it to X. Then you would go back to loop. It's not there. Optimizing too soon. So if it passes here, it means it's not. So then you copy X to. I guess you wouldn't jump to loop. You would jump to the check. No. Copy X to M. Would work. Clamp. Copy nerve to X. Test X is less than 120. And a thing for right. Thing for. Oh yeah. Right, because you're gonna be copying X to M regardless. So you want thing that is right. So this thing would be X to M. If it is not, then jump to right. Otherwise, you copy -120 to X, and then you loop. Okay, then we have to do the same thing on the other side. Check. Okay, mark, loop. We have to copy from M into X, and then with the test, if X is. Do we even need to copy? I guess we do, because if we read from M again, it's not going to work. I want to test if X is greater than 50. If it's not, basically the same thing. Copy X to nerve. And jump loop. Okay, so then for here, you want to copy 50 to X. False. It's false, then you go there. Okay. Should work, right? They're writing values. It's good. Everything's good. Alright, we got it. Hey, look at that. We're better than the mean. Also, I guess these are people on my friends list. Easy name got it in 37. 11 instructions? Activity size 11? What the heck? Oh, that works. This hotfix should keep you useful. At least for a little while longer. What's the fast way? I don't know. I'll probably find online. I'm glad I don't have a body. Get used to it. Alright. Next puzzle. Welcome, Nico Knee. Okay, we've done this one. Go to this one. We have to read. We have to continue reading. Snacks? You don't have to answer that. I know you like snacks. That's why we're gonna hack a snack factory. A snacktery, if you will. This is silly. Alright, what are we doing here? Remove the word peanuts from the peanut blast recipe. Note that the target keyword will appear in different position in each of the test runs. Okay. So we're here. We want to file 237 as the recipe. We want to iterate until we get to peanuts, and then we want to, what is it, void? Yeah, we want to void while peanuts, if it is peanuts. All right. So we have to grab file. We want to link to 800. And then we want to read, so copy. I guess 300 will always have peanuts in it. So we copy, hold on. Copy file to X. And this is peanuts. And then we want to drop, we want to pick up 209. And then we want to loop until value is equal to peanuts. So to do that, make sure to check page 36. It's page 36. To be continued? Oh, the second zine. Control EM2. 36. This is so far in the future. Yo, what the? They got Picross? Hold on. They got nonograms? What the? This is just for fun. It's not even in the game. Also, welcome, NanoDan. They also have solitaire in this game, right? Like every one of their games has solitaire in it. All right. So we grab 209. We want to loop until we see peanuts. So what do? We have to mark loop. We have to test if X is equal to F, right? If it is equal, then we delete. So mark delete. So we have to, if it is equal. If it's not equal, then we jump back to, no, then we gotta read again. Wait, but where do we copy to? How do we advance? Can we advance without reading? File, seek. Oh, you can seek forward by the specified number of values. Okay, so seek 1. Welcome, Shy Guy. You seek 1. And then you jump back to loop. Okay, and then so if it is equal to peanuts, then you will... It's probably a more efficient way to order these statements or whatever. Mark delete. So in the delete branch, then you just void F. And then drop and leave no trace. So you grab the original file, wipe it, and is it terminate halt? I think that should be it, right? So let's see. Pick this up, we go over there. Drop it. Peanuts. You grab the file. You loop until peanuts, right? So peanuts is here. We delete peanuts. And then it was not deleted. Why was it not deleted? We deleted the next thing. Hold on. Right, because once you... Okay, if it is, you have to pick up the file and... Wait, but then how do you... So you've read the thing. Oh, you can seek -1. Right, seek -1 and then void. Oh, seek -1 would have helped for a previous thing, right? Alright. Let's go to peanuts. Delete. It was not deleted? No, we seek -1. Okay, and then delete it. Okay, it has been deleted. And then we wipe and hold. Okay. Yeah. But we're not done. How are we not done? There's more than one peanut? Hold on. Yeah, peanuts. Oh, that should be it, right? Why are we not done? Peanut blind recipe. Oh wait, we read from the wrong file. We're supposed to go. Oh, we're supposed to go to the next one. Hold on. We want to link 800. We grabbed the wrong file. Grab 237. Yes. Okay, no, we're good. We're not good. Why is that not good? File 237. Grabbed 237. Hold on. Go here. Why was peanuts not erased? What? Oh, and sometimes, okay, sometimes you could read to the end of the file. Wait, hold on. Why is this not a thing? We read peanuts. Copy. Drop. Test x equals f. It's not peanuts. Okay, this should be removed, right? Seek. Wait, why was x not equal to f? What is... hold on. Because it's f. Why is f 237? No, f is... Oh wait, f should be not equal to 2. Well, okay, we're testing... Okay, f has the file ID. Wait, no, isn't that fine? That's not fine, right? Do we have to... Wait, do we have to read from... How do we compare... Read own file test. If text I've written is text you've written, delete file. Read own file. If text you've written is text. Oh, did we write to the wrong file? 300 is always peanuts. I'm not testing. Is it because we're comparing peanuts to 237, and it will never be? But how was it that way in previous? Didn't we run this before and saw that it was deleted? It's like a different file now. What? What the? Um, do we need to keep like dropping? Wait. Wait, read from x is not equal to f. Hold on. Go here. Do this thing. We grab this file. This file is what we should be removing from, right? And then we're here. X is not equal to f. I guess x will never be equal to f. Units. Okay, so this one. Doesn't testing move the pointer? Does it? Skip when also seeking one. Oh, am I skipping over? Seek one? Oh, I am. Oh, that's what happened. Okay. So when do we seek? We don't need to. We don't need to seek one. Why did I seek one before? Hold on. Peanut. Okay, we get -1. Oh wait, that's good, right? Okay, I just had that in there for some reason. Okay, not optimal. Actually, this is worse than many people. Actually, it is much worse than many people, but whatever, it's fine. You only seek backwards when you want to rewrite a file you've tested. I don't know. Why did I add seek 1? Processing. No peanuts in Peanut Blast. Was that funny? No. Imagine. It's messed up. Snacksnet. Okay, what's this one? You're gonna help Gas with his copy shop bill? That's kind of you. Sure. Zebros copies. I sure hope it does. Erase Gas debt to the copy shop by zeroing out his balance in the customer database. Appending a payment to the payment log with today's date and the exact amount of his prior balance. Okay. So his customer ID is here. We want to go to file 200, find the one that has this value, C07, whatever, and then set the balance to 0. Or is this the balance? 0? Pending the payment. Okay, do we have to read the thing that tells us what these values stand for? No. DigiCash. Is this it? Point of sale. Is this the same thing? Welcome around square. Digicam. DigiCash. Is this related? DigiCash. Storage systems. User database. Okay, this is the bank. Okay, this tells us the format. Okay. We are in fact reading the manual here. Accounts are stored in individual files, one per account. It's an account. Every account starts with 4 values. The account number, account name. This only has 3. Oh wait, what's 201 then? 201 is the payment log. Then what is 200? Transactions? What is this? 4 values. That's 3 values. What? It's not. Is this not the correct section? Set his balance to 0 and 0 cents and add the values of 0 to the payment file. So like 200 is the database. What is his what are these values then? $0. Is this dollars and cents? User ID, then dollars and cents. Okay. And why doesn't this have the format? Hold on. Credit or debit. Oh, this is a different thing then. What is this? His balance. Current day you have in the date file, his user ID you have in 300. This is the date. What the heck? All right, today. Okay, we have to write today's date to 201. That's the payment log. I see. Okay, so what we have to do is we have to go to file 200, find what has this thing, set these things to 0, right? We want to copy these values though. Set these to 0 and then like write those two values to here. We take the date, his ID, and those two values. That is a date. Today's date is this. Yes. Okay, but first we have to grab 300, link 800, and then we want to iterate through file 200. So, but first we want to copy F into X. And drop it, so now now X has his user ID. And we want to grab 200. And we want to loop until we find his ID. So we have to do this. So test if f f is equal to x, and if it is equal to x, then we have to void twice, and then well, but we want to maintain the values though, so we have to write it somewhere. Or we could have a second one. We could have the second guy be writing this stuff. It's entirely possible the latest payment in 201 is always the current date, but knowing exactly probably make sure at least one exception. The latest payment is always the current date. Wait, you want to read from the date register. Okay, we gotta have a second guy. The second guy will be responsible for writing to 201. So second guy, he will link 800. He will grab 201. That's the payment log. And then you seek to the end, right? You want to write to the end. But first you want to write the date. So you want to you want to link to 800. You want to go to 801. Program X's into other X's? What? How does that work? Want to link to 801. And then you want to copy date into X. And then you want to go to -1. To grab 201. Seek to the end of the file. And then you want to write the date. So copy X to F. And then you want to wait for M to get his ID. So you want to, I guess the first guy doesn't need to have his ID. This second guy could have his ID. No, but the first guy does need his ID. Okay. copy from M to the file. Now this first guy will have to write the ID to M. So copy F to M as well. So now this guy has he has written the date and the ID. And now you want him to read the two values afterwards. So we go back to the first guy. He's testing for the ID. If the ID is equal, then the pointer will be at the next two things. You want to copy from the file. If f is not equal to x, then you want to go twice. You want to advance twice. Seek 2, and then loop. Exa can birth other X's with their own instructions? What? I don't know, that's too advanced for me. And mark loop, you want to test if X is X. So if it is equal, then you want to jump to if it's not equal, you want to skip it and then go back to loop. So you want to jump back to loop. Okay, and now if it is equal, you want to you would like to copy the file to M, and then copy to M again. Right, and then you want to seek -2, void twice, and then write 0 through the file, and then drop, and then pick up the original. I guess you could delete the original file after you've tested it, right? What was the original file? 300? 300. So you don't need to drop, you can just wipe. Okay, then this should be done. And then this guy has written 2 values afterwards. So he should also be done. Drop and hold. Okay, so here's what's gonna happen. This guy's gonna pick up this file. He's gonna send the ID to this guy. This guy's gonna go here, pick up the time, write it to this file. He's gonna write the ID he received from this guy to the file. And this guy's gonna loop through until he sees the ID. And then he'll read the next values, transfer it to this guy. He's gonna write it, say here. And then he's going to go back to clear twice, and then write 2 zeros. Yes. So we will see now what happens. Okay, he's written today's date. He's waiting. Appears that something is stuck. What happened? He's halted. Why did he halt? He's done. Okay, something here's wrong. Something here. Okay, he's testing. If f is equal to x, the value that you've read from the file is equal to the ID. T jump to equal. Hold on, let's go do this again. Let's look at this guy. Link, copy, copy. Cannot read past end of file. Why is he trying to read past end of file? Wipe. Wait, does wipe? Do you need to be at the beginning of the file for wipe? No, right? Where's wipe? Also, what the heck is swizz? Swizzle? Swizzle the value of the first operand using the value of the second operand as a swizzle mask? It's to rearrange digits. Alright, whatever. We don't need to know that yet, presumably. I hope. What was I looking for? Wipe. What is wipe to? Delete the currently held files. Yeah. That's fine, right? Why did it say you can't read in the file? RAM 200. Hold on. Okay, you've copied F to X. Right. So now it has the ID in there. And you also want to, oh, because, okay, we tried, no, we want to copy, let's see. You want to copy X to M. Yes. That's what the issue was. We were reading from the file twice. Okay, so now this guy writes a date. And he writes the ID. And then this guy does this. It's not equal. He seeks the next one. He tests it. It is equal. Is it equal? C007. Yes, it is equal. So he'll read this. He'll send it to this guy. This guy will now write it. Hold on. Why is he not writing it? I have to nap. Hope I continue with this in particular. Exapunks in particular. That is pretty fun. I don't know how engaging it is for like people that haven't played the game. Right, I know you've played it. I know Slimeholders played it. And Zoli's a programmer, so he understands. But like everyone else, they're just like, I don't know what this is. What the frick is he doing? Opus Magnum. I did buy Shenzhen IO though. That's the other one that I had. Hold on. So why is this guy not writing? Wait, where the heck is XB? XB's done? Hold on. His copy. Did he not copy thing? Can we copy this to there? Copy M to, oh, because I didn't finish this guy. Copy M to F. Copy M to F. Okay. Right. Okay, so he copies the ID. This guy should now write the value. Okay, he's written the value. He's written, hold on, what? Yeah, okay, he's written the value. And then this guy should now go back to and delete these two. He has deleted it. He's deleted. And then he should write zeros there. Yes. Oh wait, no, I've overwritten something. I guess I don't void it. If I just write, hold on. Is that correct? I messed something up here. Something here is wrong. Hold on. Seek -2. Hold on. Can we go back here? What do we do into this file? So we go. Okay. We've read this. We've sent it to that guy. We're here. Now we should seek -2. So now we're here. And I wanted to void 2 of them. So this thing should be deleted. 20 should be there now. It is. Okay, void F again. 20 has been deleted. And then copy 0 to F. Right. Okay, but it overwrote something. I didn't know that copy overwrote something. Okay, so we don't need to void. We just need to copy. Alright, then what? Is this it? Is this good? Okay, no, that's good. We're good. We're good. Look at that. It seems like there are 2 different solutions here that many people have done. All of them have different strengths and weaknesses. Shenzhen is way too hard. Opus Magnum is too easy and brute forcey. Infinifactory is a nightmare to troubleshoot. Man, what about Space Chem? What about TIS 100? Is that copy shop name unusually weird? It's an outlier. What is Zebros supposed to be? I don't know. They're zebras, but also bros. Meeting. Okay, we have another cutscene.
Hello? You in there?
Isadora. Yo, Isadora? That's Mahjong reference.
Hey, I brought you some snacks.
TIS 100. That's the one that I don't understand. It's just like a bunch of squares where you type assembly into.
It's well, it's peanut blast.
Chemistry one. I think the chemistry one is Space Chem. TIS 100 is Shenzhen, but no visual flair. Yeah, like, it doesn't look appealing to me. I saw the screenshots and I was like, I don't know what this is.
I guess there was some screw up at the factory, so now we have a bunch of these that we can't sell.
I did that.
Seemed like a waste to throw away.
Non-peanut containing
I hope you're
peanut
doing
blast.
okay. We should hang out again some. I don't have a lot of free time. Working at Last Stop's really. Speaking of which,
There's another
I should
chemistry
get
one.
back. Take care, okay?
Who knows? Let's get next one. Okay, the highway sign. There was a thing in the book about a highway sign. Kind of slogans. Selection of them. Okay, what are we doing here? Yo, Ember, write Ember 2's message. File 300 to the highway sign. The file contains one character value for each position in the sign, left to right, top to bottom. Left to right, top to bottom. Okay, we have to look at the instructions for the highway signs. Okay, so values correspond to letters. Once you're in, these signs accept messages in the form of a series of 3 number packets written to data. First number is the row, second is the column. The third corresponds to the character you want to display. There's a few more registers. You can clear the sign. Okay, so you probably want to clear the sign first. Okay. So row, column, and character. File contains one character for each position on the sign, left to right, top to bottom. I want to grab 300, link 800. I want to write something to the clear register. So copy 0 to CLRS. It should clear. And then we want to how many columns are there? Is this all of it? 1, 2, 3, 4, 5, 6, 7. I guess we could just read through. Is there a division here? Could divide by. No, I guess. I want to keep track of an X and a Y. So, how do we do that? What is the data? There's 7. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do I want to? Am I counting this manually? There's 9 in there. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's a 9 by 3 grid. So we want to read. How do we Do this. Do I want to have like a second file that's maintains? It would maintain the row, and then another one for column. No, there's gotta be a better way. Also, let me hydrate. It's 7 p.m. Alright, I've hydrated. Okay, so we want to write. We gotta write. We gotta iterate through. Man, I wish we had more than one register for things. We'd have like a second exa that just maintains number. I don't know. Wait, I guess we could do that. Is there modulo? I guess we could just mod 8. Hold on, I know. Okay, second guy is gonna go link to 800. He's going to copy. I guess 0 is already in X. So X will be, you'll receive the letter from M, and you'll use X as your counter. You'll count how many letters you've received. So we mark loop, and then we have, hold on, let me make sure there's modulo. Does modulo exist here? Or maybe there isn't. Maybe there is no modulo. Is there? Mode, void. Random. Code a burger machine. I don't know how. Test. We have a file we can drop. Void. There's no modulo here, really. What is swizz? Swizzle the value of the first operand. What is swizzling? Input mask result. Oh, I see. This is unrelated. We don't need this. This says to take the fourth value and put it there. Wait. No? 1, 2, 3, 4. The value of the second. I don't know. We don't need this. You think this game can serve as a tutorial to encoding? Maybe, I don't know. Maybe. It is kind of complicated. Of people that don't know how to program, I don't know if this would be like a good introduction to programming. Oh. Welcome, Wizbright. So there's no modulo. Oh, there is. Well, no, there is. Hold on. They just didn't list it as its own thing. Okay, well, they have it here. So we do have modulo. Okay, so we want to, the second guy is going to increment add I to X and 1 and store the result back in X. This will be at the end of the loop, though. So... okay, first guy's gonna clear the sign. And then he's going to read from the file Okay, copy from the file to M. You're just gonna loop until EOF. So test F. What is it? What do you do? How does EOF work? Test EOF. Okay, it's just test EOF. I was thinking it might be better for people who are already familiar with this stuff. Yeah, like people that don't know programming, you're looking at this and you're like, I don't know what this is. What even is he doing? So test EOF. If it is EOF, then you're done. If it's not though, F jump to loop. Mark loop. So this is the loop. And if it is EOF, then you wipe the file and halt. Okay, now the second guy, he's going to be copying from M into data. He's going to be copying from M into data. And then, oh, but he has to, okay, first he has to copy row and column. So you copy row, divide, you gotta divide. Oh, but then how are you gonna... Hold on. Oh, no, I know. You gotta... Okay, so you gotta take the value. You gotta divide I of what's in X. X is our counter. So you want to divide from X. Divide by, I think it's 9, right? There's 9 things here. Divide by 9 and write it into data. Right, you write the row. Wait, what comes first, the row or the column? You write the row. Okay, so the row, yes, that is correct. You gotta divide. And then you gotta mod X at 9 and put that into data. And then you copy the value you receive from the first guy. And then you add, and then if X is equal to, what's the end? If X is greater than 27, right? I guess it'd be greater than 26. It's greater than 26, then if it's not, then go back to loop. Otherwise, then you're done, right? Then you have to halt. Okay, let's see what this is. They're going there, they're doing this stuff. Meaningful character, okay. You cleared. You wrote the T. We were writing the messages. Yo, look at this, they're writing the messages. Now, okay, there's zeros, there's zeros. Here, this should be written here. Or maybe here. It should be here. It is. Yo, it works. Can you believe this first try? I got it. I got it. Got the messages here. They're writing. Wake up, sheeple. Question your reality. Okay, got it. Easy. Pro gamer. Maybe not the most efficient, but something. Something out there. All right. Excellent. That was a great test. Welcome, Calfriend. Take the data, processing. Okay, next one.
I have an important question for you.
The voice acting.
Imagine there's an out-of-control trolley and 5 humans tied up
Trolley
on the track
problem? Are we gonna have to solve the trolley problem in this game?
Maybe if...
Blowing up the trolley?
No, that wasn't the one I was recalibrating. Say you had a friend, and you knew the friend could help you become stronger. Would you ask for their help?
I don't know. I lack
Let's
information.
say it was a situation where the friend had to sacrifice something in order for that.
I don't know.
Okay, good to know. I'm going to process this information.
That's cool. Unknown network 1. I don't know. Something. Just give me the puzzles. Alright, what is this? Find file 276 in the network and bring it back to your host. Exa cannot grab a file being held by another Exa. Find file 276. I don't see it. Where's file 276? Where even is it? Binary search. I can't believe this. I can't believe this. Alright. Is there like anything about this in here? Any useful information? What's all this? Binary search. I don't know where it is. That's it. That's the game. Reading to find where things are. Databases. Okay, well, what can we do here? An Exa cannot grab a file held by another Exa. So what happens if we try to grab file and it doesn't exist? Grab. Because how do we test that the file exists? Runtime errors. It'll error out and die. Is there a way to not die? You have an egg. How do we check whether file is real? Grab file. Movement. Link host. Copy the name of the current host. REPL. Create a copy. Replicate. Okay, you know, REPL means something else. Read eval print loop. But here it's to replicate. If an Exa is holding a file when executing a REPL instruction, the file will not be copied. Okay. So we have like the same code, and then we can replicate. Okay, we can go here. We can replicate and go both ways. Do I think I could fit all of New York's rats in my flat? No, I seriously doubt it. Okay, so we have to mark. This is a split. This is when it splits. So first we have to go to 800. We have to link 800. And then we have to REPL split. And then this is the split. Now we're here. Now we have to, one of them's gonna have to go to 800. One of them's gonna have to go to 801. But how? What happens to the one that is split? Oh, the copied one. Okay, the copied one can go to 801, and then we can go to 800. Maybe. So, REPL split. And then we have to go link 800 again. It's probably a better way to do this, but I don't know. We go to 800. And then, like, how do we know the file exists though? Make grab. Like, what if the file? What if the file doesn't exist? Won't we simply just die? Oh, we have to bring it back to the host as well. Okay, so okay, let's just try, like, if we link, let's just try grabbing the file and see what happens. If we grab a file that doesn't exist, 276, right? If we just grab 276 and it's not there, what happened? File ID not found, and then it dies. So, like, so then what? Then I want to have the ones at the, oh wait, hold on. The ones at the end. What if you can't, what if we go to the end and we can't go? If we can't link, what happens if you can't link? Link. So, like, what if we link like 900? It'll say link, we could not link. But does the thing just die? Link ID not found, then it just dies. Okay. Yeah, link. The Legend of Zelda. Okay, but it's fine if it dies though. So here's what we're gonna do. We're gonna go, we're going to go split. Right, the first one goes to 800. The second one goes to 801. And then you what if you did this? What if you did this? Mark loop. What if you did? What if you jump to loop? So that, look at this. This is branching logic. They branched. Okay, they branched, but not in the way I wanted. What? Okay, we have. Wait, why did this not? It goes here, right? And then. No, they should be. We should go to 800 first. Maybe the one that branches should go to 800. Right, that goes there. That one's dead. Oh wait, but then how does this one? We need to have this guy. This guy should be linked first. This should be what happens, right? He goes here, and then he splits. And then, wait, but then they're not going. Why did this one not go there? Hold on. Link 800. This guy goes here. This is the loop. Split. So the split one goes to 800, and then we go to 801, right? Split. Right. He goes to 800. Oh wait, we should be going back to loop. Right? Yeah, okay, now we have a thing that visits everything. But then now we need to try to pick something up. But how do we... Let me do that. Hold on. So now they've all gone there. They're all at the end. How do we know they're at the end? is if you try to go to 800 and there's nothing there, then ah man, game is hard. What if you had a thing? What if you had a thing that's a read? So this one will have, what is it? Take, grab 276. And then what? Hold on. Let me do this. Go there. But we want someone to stay behind, actually. Right? Maybe. Yeah, that's a problem. No one is staying behind. Everyone's going there. So I want someone to stay behind. We have to, do we have one that's for the left branch and one for the right branch? Can mark a left and mark a right. But then, like, they're kind of doing the same thing. Oh, we mark loop. And then we want to REPL read, right? We'll have one guy go here. And then another guy will be... No. Wait. Wait. So we want to go here. Yeah, but we need a guy back at the beginning as well. Hold on, we want to go here. Someone stay behind. Welcome, Yurga. So we want to REPL loop. Oops. Maybe I shouldn't have called it a loop. Jump read, maybe. Here, this goes there. Goes there, that goes there, and that goes there. No, but there's nothing to read. There's nothing even there. We need to delay. Okay, hold on. We can go here. No. Can't work core games. They sure are. So then jump, read. We want to jump and also read. Anyone out there jumping and reading? REPL loop. We want to go somewhat splits. And the person stays behind. Maybe... What's my algorithm here? What are we doing? Maybe I'll just restart this whole thing. Just reset everything, forget what we had. Okay, so first you want someone to stay here. So we want... Stay. I don't know what to mark. We have mark split. Right? So the guy that stays, he waits one. But the split one, you have one. Okay, hold on. Mark left and mark right. So the guy on the left goes to 800. The guy on the right goes to 801. And the guy who stays, he waits around a bit, and then he reads, and then he goes to -1 if possible. Left. Link 800. Right, they go there. And then you have to go And then you have to and then you jump to stay. Right. Okay, now jump before stay. You have to repel left, repel right. So this should then, that guy stays, that guy goes there. What, why are they not staying? Hold on. Link -1 though, if possible. Okay, something, this is doing something. Okay, there's too many, there's too many things here, there's too much. I don't know what's happening. Okay, so one guy goes to the left, one guy goes to the right. Okay, link, and jump back. But they have to try to grab the item. So, grab 276. Link -1. Well, but you might need a delay to wait for the other guys to finish. You go left. One guy goes left. One guy goes right. No. Yes. Yes. Okay. No. No. What's happening? It's complicated. This game is crazy. What are they doing here? This thing, go left, go right. Try to grab file. We need a delay, right? No, do nothing for 1 cycle. Do nothing. No up. What if you did no op? But you have to do a no op for a while. Maybe. Do we need this? Do we need maybe test MRD? This exa could read from another exa without pausing. Maybe. Maybe if we have the file, if someone has the file, we could use the M register to signal that we have something. We could copy 0 to M. Which would tell them. Hold on, then you have the file, right? Then you link -1. Dude, I don't know. It's hard. It's tricky. I don't know if I can solve this in like the next 15 minutes. Maybe. You know, maybe we'll check out the next one. Huh? Let's do this one. Surely this one will take even longer. There's another file I want to grab. Sure. Alright, what's this one? UC Berkeley, that's a real college. Locate the specified host, either tape 1, 2, or 3. And then locate the specified entry. The tape backup. And that host. Couldn't you assume you had the file? I don't know. Yeah, because like it would die. I don't know. problem. It's complex. We want to see more problems. Locate the specified host and then locate the specified entry in the tape backup file in that host. Create a file in your host containing the entries and data. Okay. Names of target host and entry are available in file 300. Accessing data in legacy storage systems. Oh man. Is it in the second one? Accessing data, legacy storage systems. Tape storage systems were used. They contain backup entries, hard drives, files. Dude, what? Okay, tape 3. I want to go to there. This is like another branching logic thing. Oh, it's a one-way. Okay. It's not branching. It's a one-way path. You can go to 800. You must go to 800. Okay, you link to, you gotta grab. Grab 300. A link 800. Then you want to read which tape you're on. How do we know? How do we know? Tape 3. How do we know the host we're on? Is there a command for that? Host. Host R, okay. So we want to copy host, the current host into X, and then we want to test if the thing in our file is the same thing as what's there. We want to test whether we're on the right host. Test X is equal to F. We have read from the file. And then, if we are, then we want to grab the file. So, mark loop. Okay, this is the loop. And then, if it's not equal, you want to go back to loop. Otherwise, now we're on the host that has the file. And we want to we want to drop the file. We want to grab I guess if we're there, before we drop, we should avoid the file because we know we're on the right thing. So we can pick up the file again to determine what thing to read. Do we need to avoid it? I don't know. Copy F to X. And then drop. Okay, now we have this thing there. Now we have to make a new file that copies all of the things from here. Maybe. No, wait, hold on. Okay, the entry. What is the entry? The entry is this thing. Reading from legacy systems. Tape storage. Which tape contains 0 or more backup entries? Entries start at the beginning of the tape, concatenated sequentially, making it impossible to tell which data belongs to which backup entry. Metadata for the entry is stored at the end of the file in 3 value triplets. The first value is the entry's name. So this is the name. The second value is the offset in the data stream where it starts, and the third value is the length. Okay, so it's like the length delimited. We have to like go to the end, find this thing, jump to the 53rd entry. We want to seek to 53 and then read 18 things. Okay. So we want to grab file 200. We want to seek to the end. And we want to go until we've seen value. So we want to mark find entry. Right. To seek -3, right? So we're at the end of the file. We want to go -1, -2, -3. Okay. Seek -3. And then we have to test whether the file is equal to what we have in X, right? Because X is now holding this thing. And then if it's not, then we go back to find entry. Right. But then if it is, then we simply have to jump. We have to, okay, we have to jump. We have to seek to this location. Copy this thing. So if it is, we want to put this in X, and then we want to go back, and then how do we store 2 values? Common problem, storing multiple values. This comes up pretty often. We want to store copy file to X. So this tells us where to jump to. And no. I want this to be stored somewhere. Do I want to like make a file and then like write the things in the file? That seems kind of annoying. Or no, we could have a second one. We could have one person that's like one. We create a new exa that starts at the start location. Yes, we're gonna make file. Is it make? It's make, right? Then we gotta know the ID of the file. No, but you're holding the file. If you make the file, you're holding the file. So this guy finds the entry, right? Then he has to copy from the file, right? He'll copy this thing into M, copy F into M again, copy F into X. Wait, why am I doing that? Why am I doing that? Why would I copy? No, we don't want that. What if this guy sends the value back? We use this guy to store the original offset. Yeah, actually that works. Okay, we can copy, hold on. We can copy F to M. Okay, we read copy from M into X. and then we send it back. Copy X back into M. No, we copy, wait, does that work? What am I doing? Copy F into M. Copy F into X. And then this guy now has the offset in the file. But you want to not do that. And copy the file. The next entry in the file tells you this thing. So then what? To seek. Hold on, you should do a no-op. This guy should now copy, wait. Copy that to there. Take that one, you do a no-op. Then copy from M. No. Can you seek M? You can just seek M, right? You can seek from the next value. So you copy X back into M. So this guy is now at the right offset. Now he has to read data. You want to add I, X, 1, start back into X. This will be at the end of the loop. Now you want to sub I. Sub I. So you want to copy from file into M and then read until the offset. And then test. If X is 0, then you're done. So if it's not 0, go back to read data. And then you have to grab the file. Have we deleted the file yet? Okay, so you want to wipe the file. And then you want to halt. Now this guy though, this guy has its own write data. Copy copy M. But then how do you know you're done? You have to like, hold on. Copy M to F. You have to check whether you're done. Void M. Test if this could return another exit without pausing. Maybe that could be something. Yeah, you can't tell if M is end of file. That's the issue here. I could have like a special marker. You probably don't want to do that. Okay, well, let's just see what this does. If this works, this could totally be wrong. That's it, right? This one has to go to the right host. It has to go... What just happened? This guy just died. Go there. You link 800. And then link 800. The host is not the same. host is null, x is not equals f. You go to the next one. Host x tape 1. Is x equal to f? It's not equal to f. Oh, because we're at the end of the file. Okay, we have to then seek 0. Have to go back. Wait, why are we testing for the file? Why don't we just read? Oh no, because x goes to the file. So we do have to seek 0. Okay, this should now go to the next one. It does not. It did not go to the next one. Why didn't it go to the next one? Have to go there, and then you go here. Host x. Okay, that is now tape 1. You seek 0. You can't seek 0. Oh, you have to seek negative. Sorry, it's relative. Right. Seek negative 999. Right. There, you go there. You go to the next one. Okay, now he's on the right host. I guess it's on the right host. Seek to the beginning of file. Jump void f. Okay, and then you copy the entry into x. That's there. You grab 200. Okay, now you seek to the end. Welcome, Chaos Ryan. You seek to the end. And then you go until you see this entry. Right. Test f equals x. F is in fact equal. Okay. So then you're in find entry. Then you copy 55 to m. Right. 55 is now in m. And then it has been read by this guy. And then this guy does a no-op. Does nothing. And then he copies. Okay, now this guy has copied f into x. He has the length 18 in x. And then he wipes the file, right? Cannot delete this file. What? What the frick? Wipe. Cannot delete file. Why can't you wipe this file? Oh, because you're holding. Wait. No, I wanted to wipe the other file. Hold on. Copy f to x. You want to grab 300 and wipe 300. And then grab 200 again. I guess you don't need to seek, right? No, you do need to seek. Okay, we go here. He goes to this one, he goes to that one. I'm gonna end the stream soon. It's fine. Okay, do this. Okay, now he has the file. Seek to -3. You have this one. Send it to this guy. You send it back. Write the file. Cannot grab a second file. You have to drop. To drop. You go here, you go there, you go over here. Okay, you have the file. You located the thing. Okay, you drop the file. Grab the old file, you wipe it. You grab the new file. You seek. Okay, now we should be seeking to 55. We should be seeking to 55. Yes, we have seeked to 55. And then we copy the file. We copy this value to m. Right, and then this guy will now, this guy over here, he's going to read it from m. He's going to copy it to the file. Yo, they're going. Look at this. They're writing it. And then this one goes up until it reaches 0. Right? Okay. Now he should terminate. But now this guy is stuck in a loop because I have him doing nothing else. So like, then what do I do? Then welcome Jimmy Matt. We have to check. We have to check if test MRD. Wait, data test MRD. If you could not read anything, if it's not, hold on. If you can read without pausing, set to 1. Okay, so you have to T-jump to write data. Otherwise, halt. Check this out. I can't do that. What is this? What if it's a virus? Corpse channel? I can't believe Corpse channel would say this. Okay, what's happening now? Why is this not happening? Read data? Halt? Jump right? Maybe I need a no up in here? Here. It's not working. What's in the file? What is in the file? It's over. Do I need 2 no-ops? It's not working. I have some very violent emotes. What do you mean? What did I do? Why is this not working? T-jump, write data. If this is true, can read without pausing. Maybe I have it inverted. F jump. Have we written the file? File on the host? What file are you holding? It's done, right? That's done. Why are you not done? If you could not read it, then what the frick? I don't know. Okay, I think I'm done. I think I'm done here for today. Interesting game. It's quite difficult. I think that's it. That's it for today. I hope it saves my data. Hold on. If I go back, does it have my code? It does. Okay. I don't know if I will be revisiting this, but you know, from a streaming perspective, I don't know how good this is for people to watch. It probably makes no sense to many people, but I like it. Anyway, that's going to be it for today. I'm going to find someone to raid. Can't find what day it is. A baby massage day. Day of Romas. Draw a bird day. A bunch of days. Zoo lovers day. Pygmy hippo day. Step into the spotlight day. Dog fighting awareness day. Let's do this one. This one's also good. Empanada day. Another nice food related thing. Let's do this one. So thank you, Toltage, for your Prime sub. Draw a bird. Can't type. Draw a bird. Bird day raid. You can post a bird emote if you want. I don't know. Alright, who's streaming? Did you know that Choco Jax is not streaming? Because she's on vacation. Alright. Who's streaming? Who's out there streaming today? A bunch of people out there streaming. Let's raid wait a second. This person is not normally streaming at this time. Marley? Let's raid Marley. She raided us recently. She's been streaming for 7 hours. Okay. Anyway, yeah, thanks for watching. I will be back on Wednesday. That's right. I will not be streaming on Tuesday, tomorrow, because I have work in the physical office. We have 36 people here. We did get raided, like, at the start of the stream. I'm going to assume that those raiders did not stick around. That maybe these people are just people that are browsing the exapunks category on Twitch. I don't know. Possible. Anyway, yeah, I'll be back on Wednesday with fishing, and then not be streaming on Thursday because I have work again. I mean, I have work every weekday, but I mean, I'll be in the office, which is the different part. Then Friday we got Picross. If you like thinking games that are not programming related, Picross, that's Friday. And then Saturday we got various games. So that should be cool. The raid is going soon. So thanks for watching. I will see you next time. Goodbye.